Find the exact value of 5 pi over 12. So for this one, I'm going to open up my reference angle chart. Usually when it says find the exact value, I'm going to be dealing with some type of reference angle. All right, so I look at some of these and I try to find out, all right, well, which of these angles is 5 pi over 12? And I realize none of them are. So this is going to require me to do a little bit of identity work. And in this case, what I want to do is I want to come up with two of these guys here in green that you can barely see. Which two of these could add or subtract out to 5 pi over 12 so that I can write it out as tan something plus something. Okay, well, if I were to add pi over 6 to pi over 4, that gets me 2 pi over 12. This gets me 3 pi over 12. Adding that up gets me 5 pi over 12. That makes me happy. Now, why does all of this even matter? What am I doing here? Tan alpha plus beta is one of those addition identity properties where tan alpha plus beta is the same as tan alpha plus tan beta. Let me write that up here. Tan alpha plus tan beta over 1 minus tan alpha tan beta. So what I can do is I could use this identity and rewrite this as that. So you would be my alpha, you would be my beta, story of my life. I don't know what I meant by that. And this gives me tan pi over 6, something that I can do because of all this stuff over here, plus tan beta, which is, that's supposed to be a plus sign, ended up weird, tan pi over 4, all over 1 minus tan theta, or alpha rather, which is pi over 6, times tan beta, which is pi over 4. Tan pi over 6, according to my chart, is going to be root 3 over 3 plus tan pi over 4 is going to be 1. According to my chart, over 1 minus tan pi over 6, which is root 3 over 3, times 1. Let's do a little combining up here. So if I were to make this 3 over 3, and if I were to make this 3 over 3, right, I get root 3 plus 3 over 3 minus root 3 over 3. Multiply the top and the bottom by the reciprocal of this guy. So I'd multiply the top and the bottom, and I'm running out of space here, so I'm going to try to do this a little bit in my head. If I were to multiply the top and the bottom by 3 over 3 minus root 3, the 3's would cancel out, and that gives me root 3 plus 3 over 3 minus root 3. Now, my issue here is that I have a root in the denominator, and that's no good. So I'm going to use the conjugate, which is the difference of squares idea, and multiply the top and the bottom by 3 plus root 3. What that does is it, again, treats it like difference of squares and eliminates the middleman. So this foils out. This foils out, eliminating stuff in between. And the top gives me root 3 times 3 is 3 root 3. Root 3 times root 3 is 3. 3 times 3 is 9. And 3 times root 3 is 3 root 3. The bottom is going to be 3 times 3, which is 9. Okay. 3 root 3 minus 3 root 3 disappears, and then minus root 3 times root 3, which is 3. I'm going to have to scooch this up. Sorry, reference angle table, but you're getting scooched up there. Thought I'd be able to make it, but I didn't. Let me move it up here so I have myself a little more space. 3 plus 9 is 12. 3 root 3 plus 3 root 3 is 6 root 3. And then 9 minus 3 is 6. I can factor out a 6 on top. So that makes this 6 times 2 plus root 3 over 6. 6's cancel out. And at the end of the day, I have 2 plus root 3. So you might be thinking, man, I really wish this word wasn't there so I could just throw that into a calculator. Well, if I had 3 wishes, I'd be Aladdin. If I had, like and subscribe.